Hello. I've done nothing yet. My name's Sam, and I am not a Java programmer. But I am in the way between now and the party, but I'm also the person who's going to make the music for the party, is to show you really how I make the music, but more importantly, why. And I think that's really an interesting question. And specifically, I want to talk about how I approach programming and who I try and talk to. So it's quite weird that I'm talking to programmers already. You're all programmers, right, most of you? And you're all Java programmers. But I think I have some very different ideas about programming and why we should program and who we should talk to about programming. Because I don't know about you, but I mean, in Russia, do you have parties? Hopefully, yeah, right? And when you go to those parties, and if they're not just like this party here, where it's mostly Java programmers, can you hear me okay? Because it's very echoey. I mean, is it clear what I'm saying? Okay, I'm getting lots of reverberation on the stage. When you go to parties and you speak to people and you say, hi, and then you say, I'm a programmer or I'm a Java programmer, does that help the conversation? No. That's a problem, right? Because if you say, I work, in hospitals, or I'm a teacher, then suddenly you can have a conversation about your work and how it's interesting, and the other person can ask questions. But when you're a programmer, you can't do these things because people don't tend to want to know more about programming. Like, it's the end of the conversation, isn't it? You say, I'm a programmer, and they go, okay. And they're off, right? And it's like, wait. I want to tell you so much exciting stuff about programming. Like, I did this crazy project, but you can't because people aren't listening. Now, why is this? Why is this the case? I think it's the case because most of society in all the world can't program and therefore can't have that conversation. I believe if they knew the beauty in code that you can see, that I can see, that they would have that conversation, but they just don't have the language to talk to you about it. It's almost like if you go to a party and someone says, how are you doing? And then you speak in a language that they don't understand. So say you're in China and you speak German, it's the same problem. Like, well, I don't speak German, sorry. And they walk away. So we need to find ways, I think, to engage a broader audience, which means more people, not just to people who themselves, like you people, probably enjoyed programming when you were young. You probably had computers and really got excited about programming them, and that just grew into your profession. Is that the case for most of you? Yeah? Did you have computers when you were young? No, you were just sitting there. Can you understand what I'm saying? Maybe you've got the same problem. Right? So the thing is, when we look at how we learned to code, it was because we loved code in itself. Its own beauty was clear to us. And that, I think, actually, that makes us pretty weird. Weird people, strange people who like programming for its own beauty. And I think that if we want to talk to more people, we need to find ways to actually get them excited by not talking necessarily about code directly, but of all the amazing things code allows us to do. The new things code allows us to do. And so I think when we're trying to talk to more people, and I think we should all be trying to do this, because I believe that code is one of the most creative, powerful forces we have, right? We should be trying to find ways to share that creative power with other people and giving them the ability to use such creative power for their own ideas and their own things, and then being able to change the world in the ways that they believe. And I also believe, and that's why it's quite exciting, to be honest, to talk to enterprise Java programmers, that code should not just be used for business. Really. Just imagine. It's a really important statement. Just imagine if Russian or English or German was only used for legal contracts. Right? Imagine the world we would live in, the barren world, with no plays, no poems, no songs, no rap lyrics, Like nothing, just legal documents. That's the world we live in today with programming. It's just for business. My head is extremely small, and this headset keeps falling off. And that's the problem. How do we try and figure out to get code out of business and into people's homes in a way that they wouldn't necessarily make a product out of it, but they would express themselves? Just like you might not just use Russian to make a legal contract, but you'll use Russian to write a letter to your friend, or to write some lyrics for a song, or write a poem. So I think we need to think about this, not just about business, but about broader things. And I think that once we can think about broader things, we can then bring more people into the discussion, which means we can go to parties and talk to people about programming. That's the goal, right? And so what I've done is I've built this system here, which I'm going to show you. I'm going to introduce the concepts behind it. And I'm going to then, later on, use the system to make music, which hopefully you're going to dance to, right? That's going to be the goal. So my goal for the next few hours, really, is to try and get you into an excited mood so you're going to dance. And so there's one more thing I need to talk about as well, is that if we're trying to engage more people, that means children and adults alike. And so I think we need to also think about how we talk to children about programming and how we get them engaged too. And I think that if the starting point for a programming experience is open up IntelliJ, it's not going to work. Just like if I said the best way to get programming is to open up Emacs, right? It's the same problem. I think that we have tools, really, really powerful tools, that allow professional programmers to do amazing things, but they're not necessarily the right tools to get people who want to start to use. And so we need to rethink these ideas. And you might have your favorite programming language or your favorite library or your favorite framework. They might not be the best tools to teach people, to get them engaged. They might be the best tools to make your business app, fine. But when we're thinking about engaging children and adults and people who can't program, I think we need to rethink how we get started and particularly simplify the hell out of everything. If you're, like, have any of you been into a classroom recently to watch some school children work? No, not many, right? You should definitely do it, right? In the UK, we have all sorts of code clubs starting where professional programmers can go into schools in the afternoon and for an hour help children learn how to code. This is something you could probably try and start in Russia. I think it would be fabulous. And you can use your skills to try and teach children how to code. And if you do that, you'll be amazed about how little information you can get across in a lesson. Like none. Like, I've seen teachers just spending most of their time controlling the children and getting them to sit down and listen. And when they've sat down and listened, the teacher can say 1 or 2 sentences. So what are your 1 or 2 sentences to teach programming? What are your 1 or 2 sentences to get someone to have their first programming experience? Because if it's open up IntelliJ, that's 2 or 3 lessons worth of what kind of project we're creating, what kind of class structures we're having, what kind of Maven dependencies we're pulling in. These are all lots and lots of complicated stuff before we've even done anything, right? If installing Maven is the first step to making some fun programming, it's not going to engage most people. And so my job was to figure out how can we make the first step as simple as possible and also specifically meaningful. Like, if your first step of programming is to get a list of numbers shuffled and then sort them, right, that might offer all sorts of ways of talking about algorithms and programming and also cool stuff, data structures. But who cares about sorting? Who's going to go, yes, I've sorted my list of numbers and run around, right? No one's going to do that. And you've got to think about what is the thing which is going to get people to get excited. Because you want to go to the parties and talk about programming. You're not going to talk about sorting things. I promise you that. You're going to talk about other things that you can do with programming which changes the world. And sorting does not change the world. So I've built a system called Sonic Pi to try and solve this problem. and I'm not sure if I'll connect to the internet. Let's just try this. But this is the website you can go to. So if you like what I'm doing today and you want to try it yourself, this is the website to go to, sonic-pi.net, and you can download the software for Windows, for Mac, and also for Debian, and it's also installed by default on the Raspberry Pi computer. So again, when we're talking about trying to get more people engaged, we need to think about simplification, but we also need to think about cost. If, like, the only way to program is to use a really, really expensive MacBook Pro, there's a barrier to entry for most people. So we need to think about how to make that cost lower. So this software is free, it's open source, but also it runs on a $35 computer. So this is, again, trying to lower the barrier to entry. So once you've downloaded it and run it, you get this environment. That's what it looks like. In fact, that's some log there. It looks like this. And so the simplest way, so my one sentence to get people to program is to write the word play and write a number and press run. And there we are, that's the first beep. And when a child does this, or an adult does this for the first time, they literally do just run around the room, because they can see that that code has made some kind of effect that they can perceive and understand. In this case, it's making a beep. All right, I just press it, there we are. And now I can change the number, and make a higher note, or a lower number. I can test the system here, see if we've got any good subwoofers. No, the subwoofer's not very good in this room. But if you're in a nightclub, this would sound amazing. A big, rough beep. So now we're able to play notes. We need one more command to make a melody. But let's try and do two notes. So this is interesting. I don't know what you expect this to do, but when I run the code, it plays both notes at the same time. So this is an opportunity for learning. So you can talk about the fact that the computer is so crazy fast. It played one instruction and then the next instruction, but really, really quickly together. Okay, so we have these two notes at the same time. And I'm going to spend the rest of the time really talking about I've just given an introduction of why I'm doing this, but this talk really is about how this is built. And what's really interesting here is that although you can explain that 70 was played before 75, but so crazy quickly it sounds the same, actually, if you look at the logs on the right-hand side, they are played actually at exactly the same time zero here. So there is some funky business going on to talk about time, and most of the rest of this talk is really about time. So if we want to make a melody, we need to have one more command. That's sleep, and then we can do a melody, right? Now this is quite fun, because if you know anything about music, like melodies and bass lines, this is most of Western music. Any melody you can hum, I can play with these two commands. Any Tchaikovsky thing, I can play with these two commands, right? Any new order track or whatever, I can play with these two commands. It might sound rubbish because it's just a basic beep, but kids love it. They can go crazy. And so they literally will do this all day and just try and see what notes they can play. Or maybe I didn't change the times. Right, so just by changing these two numbers, I can change which notes are played and how long between them. And that's most of Western music there. And the cool thing now is that, and this is an education perspective and talking to people about programming, is that although that might be most of Western music, you people can see, well, that's extremely simple. Like, you can imagine so much more exciting things we can do with those two commands. Because from a programming perspective, this is the API, right? This is just the start. What else could we do? Where could we take music that it's never been before with a system like this? This is where your programming mind should be running crazy, thinking, oh, I could do all these amazing things. Like, what happens if you wanted to change a sound? Well, we have a way to do that, synthesizer. So we can change it to like a blade sound, or like piano sounds. Right, so we can change the sound. But we can also do things like add studio effects. So if I wanted to add reverb or distortion, I don't know if you've ever used these kind of musical systems before, but they tend to be quite complicated. Imagine writing this in Java, right? Already you've got lots of more semicolons and brackets and whatever. But I normally would have to sort of have, if I wanted to have a reverb here, I'd have to have some way of saying reverb is reverb dot new semicolon, and then somehow have some way of piping this into rev. I don't know what syntax you'd use, right? And then now I'd have to have some way of saying rev.kill to destruct the reverb so it garbage collects it so the reverb isn't running still, right? And this is kind of what you typically see in these kind of systems to work with effects. The problem really is, though, is knowing when to do this. Because if I have a thread here, like this, and it's sleeping for some random time between, I don't know, 0 and 1,000, I've got to wait for this thread to complete before I kill a reverb. And if I've got multiple threads and multiple reverbs, and if I start putting this in some sort of iteration, 300 times do, right? Now I've got 300 reverbs all playing at once, and I don't know when it's going to finish, and suddenly, as a programmer, learning how to program, I've got a nightmare to deal with if I just want to have a lovely sound of reverb. So this is where, as a programmer's building systems, we can think about how to simplify this. Oh, I need to plug my battery in. Then you've got power. Hold on. There we are. We need to think about how to simplify this. And so one of the goals of this system, and if you're trying to engage more people in programming, one of the really tough goals is to figure out, how do I teach this thing to a 10-year-old child? Right, if you're thinking about any feature adding to your system, if you can think about, could you teach it to a 10-year-old child, the answer is probably no to most of the features in your system. Right? But if we're trying to engage more people, the answer should always be yes, or you don't have it go in. So all this mess, that's not simple enough for a 10-year-old child. We can't have this in our system. So how do we fix this? Well, you've got this lovely feature called lambdas, which is coming into Java soon. But this language here is just based off something called Ruby. Already has them built in. So to make this with reverb, I'd say with effects, reverb, do, and end, and it now has reverb. I can change the room size, and I can hear this reverberation. So all I need to do is to say where the reverb starts, where the reverb ends syntactically, and this with effects method function will automatically wait for all the code inside that block to complete before it then kills a reverb. So it creates a reverb, pipes all the sound through the reverb, and then destroys a reverb for you automatically. So it's like kind of synthesizer garbage collection. And the cool thing is, if I put a thread inside here, it works just the same. If I put a thread inside here, it works just the same. So it's able to wait for the whole family of threads. So it's able to know that the inside thread is a child, the outside thread is a child of the parent thread. And so it's able to do all this kind of stuff for you in a way that children don't need to care about, which also means that if you're performing late at night in a nightclub, you don't need to care about this stuff as well. So actually, it turns out that a simple system is great to work with and great to teach and great to engage more people. So this is fun. So let's try it with you can hear the synthesizer, the reverb, if I do something like this. If I take the reverb away, put the reverb back, change it to echo, and then change maybe the phase duration to 0.25, mix to 0.3. And here at this point, we have these options, which is a standard map key-value pairs, and this is because this effect is like a guitar effects pedal. Have you ever played with the guitar effects pedals? If you have a guitar, you plug it into a thing, and into another thing, and into another thing, and then into your speaker. Those things also have knobs you can change to change how much reverb, or how much distortion, or the duration of the echo. each of these things also has options like that to modify, and the system will give you documentation. So in this case, I've got 2, 4, 6, 7 different knobs on my echo to change if I want to. But I don't need to, but they're there to change them. So already we have mostly Western music, and we have studio effects. And the cool thing about these blocks for studio effects is they nest together. So if I say with effects, reverb, one symbol like this, it's going through the echo into the reverb. Right? You should all know about this because you should have all programmed in Lisp and know that code should go from the inside to the out. It's a beautiful way of working. And so this is a really nice way to express being able to play notes and passing the sound through effects in a way that a 10-year-old child can understand and does understand. And all around the world, there are hundreds of thousands of children playing with the system now. I've seen on my logs 400,000 people use the system. So that's fun, right? So, is this making sense? Simplify things. Have an editor which just opens up. There's no projects. Have the first thing you write be super simple. Have a very simple set of semantics. So play and sleep, like this. Allow things like, I haven't showed you, I've showed you can do like iteration. Like this, so actually, it's quite fun. And I can do things like do 3 of those and at the end play a sample. So I can also play pre-recorded sounds. So let's play like the Ambi Lunar Lands. That's fun, right? Maybe that sounds better at half speed. Maybe these sound better short. So release tells you how long to wait before the note should go quiet. There we are. So you can see how just very simple code can create quite engaging sounds. But this is composition, right? So what I'm doing is writing code, pressing the run button, listening to it, which is basically how you will develop, right? I don't know what kind of style of programming you're doing, whether it's like test-driven development or something. You write your tests, write the code, run the tests, they fail, rewrite the code, run the test, it fails, rewrite the code, run the test, it passes, write the next test. But whatever style approach you're taking, you're still starting and stopping all day long. And maybe if you've got a massive app, between starting and stopping, you'll be able to recompile stuff. That might take ages. Maybe it's like a 30-second wait or a minute's wait. You're scratching your head and you're fencing, reading XKCD comics. So, although composition mode is nice, where it writes some text, what's much more fun, really, is where you want to be able to change it as it's running. Right? So, let's think about this. I might have a loop playing bass drum house and sleeping for 0.5 seconds, like this. Right? That's kick drum going. Right? And I might want to have another loop going like this. Bass drum like this, see for 1 second. And kids want to do this, right? This is what they want to write. They want to say, I want to play the bass drum at the same time as my drum and bass sample. But it doesn't work, obviously. Can anyone tell me why? Can you see why? Because the first loop captures the code, the execution context, and just keeps it there forever. So loops are terrible things, really. They're like black holes. They suck in the program and keep it there forever, right? Which maybe is what you want if your program is just reading off a socket forever. But if you want to change it to read off another socket, you've got to have a way of stopping it and starting it with a different socket. Or if it's playing a bass drum and you want to play a different bass drum, you want to be able to change it. But also, you want to be able to play them at the same time. So this system here, live loop, actually solves both of those problems. The first problem it solves is that each of these live loops executes as an independent thread. Right? So there's 2 threads which are about to start. One thread playing the bass drum house, and another thread playing the bass DNB F sample. Right, where it gets good, right? But these threads also have a special property that I can modify them as they're running without losing time. What do I mean by that? Well, I want to be able to run this, maybe comment this out, it's gone. Maybe change the cutoff value of this to be 70. Maybe bring it up. Right, just slowly bring it up. And then bring this back in. And then maybe change its pitch. Maybe pass it through a slicer effect. Right, all whilst this thread's still running. Change its amplitude. Put reverb around it. And swap these things on the fly, right? Now, I'm not trying to say this is like a fabulous musical performance. I'm just giving a demonstration. Later, I'll do the performance. But what I would like to say is that I believe that all the constructs in this code I've just shown you, which have made that music, every single one of them you can teach to a 10-year-old child. Right? They're all very simple, but combined together, you've got some really powerful abilities. But it also asks all sorts of different questions, right? So this sleep, what on earth is that? Right? How do we think about that when we program? When we program, typically, sleeping, why do we use even sleep? Maybe just to try and add some delay, perhaps to try and trigger some race conditions, or to try and persuade them to go in different places, or maybe have a fast loop that you want to slow down a bit. But you don't tend to really talk about time when we program. What we care about typically when we program is that I want to do this job before this job, right? And so we have all sorts of ways of synchronizing this. Well, the easiest way is to use a single thread. And so this job's a function. When it's finished, I'll do this job, right? Or I'll call invoke on whatever my invocable thing. But if we want to do it concurrently, then maybe I want to run this job and then wait for it to finish before running this job. I have to have a way of telling it it's finished, such that if I have a faster computer, it can do the work faster, right? But it still does it in the correct order. Just like I need to put my apples onto the truck, right? But if I'm still putting the apples into the basket here, and I put the basket onto the truck, and the basket is only half full because I haven't finished putting the apples in, then I'm going to drive away with only half of my apples. So I obviously have to wait till all the apples are in the basket before I can put them in the truck. So we tend to care about doing A, then B. But what we don't tend to care about is doing A every second or every half a second. But in music, we really do. We really care that that is half a second. And so this can't be normal POSIX sleep. Because what does POSIX sleep do? It says, wait for at least half a second. And then the scheduler, whenever you're ready, pick me up, which adds a delta delay on every sleep. But also, don't forget that this computation here also takes some small amount of time. And so if we have a loop going round, then what actually happens is line 3 takes some delta t, the scheduler takes some other delta t1, and then we add them together every time around the loop. And what we get is what we call drift. And that thread slows down. It's not going at the right rate. And if we have two threads with the same problem, they have different drifts. Oh, and then the garbage collector just kicks in, stops everything for a bit, and lets it go again, which of course adds another massive delta to your time, which is completely non-deterministic. You've got no idea when the GC is going to kick in. So this just won't work. So we need to think about how we fix this problem. And so what I've done is I've built a system which allows you to talk about this in the same way you would reason about it. I actually just want to sleep for half a second, so that's all I want to do. But what it does is it takes account for the time of the computation, and doesn't sleep for 0.5, always sleeps for less than 0.5, but sleeps such that the thread gets to the right time. So it says, what was the time when I started? What time should it be? What time is it now? And then I'm going to sleep for that difference. So if you have a slow machine, that might sleep for 0.4. If you have a really fast machine, it might sleep for 0.49. But it's always sleeping just less than 0.5 to keep the thread within a fixed boundary of time. And this is important because if I actually put a real sleep in here, like a POSIX sleep, thread, is this right? No? Oh, sorry. What is it? Kernel. Sleep. I will get, should be, here we are, a thread timing exception, right? So the thread itself got too far behind where it should have been, so the computer just says, can't do that. So there's this system also makes sure that the threads are all within the right amount of time. So we have multiple threads executing with logical clocks, all spinning around, all making sure they're all roughly within the right amount of time. And then the way that makes this sound is this sample command sends an asynchronous message over the network to a remote server, which is running locally on the system, which receives messages with timestamps and honors the timestamps. And those timestamps are the logical time in this. Now, that's probably a bit too quick, but I wanted to try and explain to you, like by saying lots of complicated things very quickly, that this simple code isn't actually simple at all. But the interface is simple. But to make it work, there's all sorts of crazy stuff. And I've even got like actual proofs in Haskell to describe this timing model to make sure that it really does do what we want it to do. So that's quite fun. So timing model. But there's another problem as well, right? So now I've solved the problem of having the ability to have multiple loops run at the same time, and solved the problem of, also, how does this work in terms of the live coding? Can anyone guess how I can change this? How does this work? What on earth is going on here? So the way this is implemented is that we have the ability in Sonic Pi to create threads. I have to have my own special thread construct so it's able to keep the relationships with things. And that thread's body is to loop calling a function foo, like this. Right? This is the body here. And I can define foo to, I don't know, just play the sample bass drum house and sleep for half a beat. Right? So this is actually the complicated way of writing this. But you can see what's going on, right? I have a function, and all that function does is it plays, let's just look at it in bits. If I call foo, it plays me the bass drum house, waits for half a second, and stops. So if I call foo, 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 right, this is going to work, okay? So obviously now we can imagine looping over this, and now we have something which approximates our behavior, but it doesn't allow us to do the live coding because of an important property which I haven't explained to you yet, that every time I press this run button here or hit the shortcut, it creates a whole new thread to run the code in. And that thread runs concurrently with any other thread sounds. We can see this quite easily if I do this sample ambi lunar lands. Whilst that's running, if I add another one, I can layer the sounds on top of each other because now I have multiple threads running at the same time, and they'll all stop when they finish their sounds. So when you press run, it does not wait for any of the previous code to have finished. It just adds another thread into the system and just says go. And so over here, if I have this going around, and maybe now I want to change this to have a different rate, what I'm doing, every time I press run, I'm creating a new thread, and that's adding to the previous thread. So at that point, I had 3 loops going around at the same time, which is obviously not necessarily what we want. We probably just want the 1 loop to have new behavior, not 3 loops with a new behavior, and 4 loops, and 5 loops, and 6 loops. And so we have to solve this problem as well. How do we fix this? So what I've done is I've created a system where these threads can be named. So I can create a thread called foo. Now, if I change this now, has our behavior, because these named threads have a special property that if one is running in the system and you try and create another thread with the same name, it's a null op, it just doesn't do it. So what happens is the first time I press run, I define foo, great. I then create my thread called foo, which is spinning around calling foo, great. The second time I press run, I redefine foo. Maybe it's got the same behavior, maybe it's got different behavior, it doesn't really matter. But then I try and create another thread called foo, but it doesn't do that. So the effect is that the behavior changes. And so this is a great way to do live coding, right? But does it pass the 10-year-old test? No. Right? There's lots of bits, functions, threads, name threads, loops, function calls, right? This might seem to professional programmers like you very trivial, but it's not trivial to a 10-year-old child, which is why the live loop really does all of this, right? The live loop is a function, is a name thread, and is looping, calling it. That's what this is, right? So it's just syntactic sugar for that exact complicated thing. So yes, so now I've solved the problem of concurrency, I've solved the problem of live coding, I've solved the problem of timing, but when we start to perform with this, we get other problems. Because watch this, right? So if I have my bass drum going around, and I've got another live loop called bar, which is playing the loop industrial sample, which is pretty cool. I'm going to beat stretch that to be one beat. Let's stick to one. Right, we're going parting. So off we go. Of course, when you're coding, you make mistakes, right? Oh, damn, made a mistake. So I've got a runtime error. That second thread has died. The first thread is still going, which is great. So it gives me an opportunity to fix the error. That was good. Let's break it again. Let's fix it again. It's not in sync. Can you hear that? So although you might have a thing where you have two threads and they're working beautifully in time with themselves, and when you start them both, they start at the same point. They go round and round. It's great. Or maybe one's going twice as fast. But when you kill a thread accidentally and restart it, it starts when you press the run button, which means that it will be out of phase with the other thread. Does that make sense? Right? So they'll be spinning around at the same rate, but they won't start at the same point. So it'll be ka-chish, ka-chish. It'll be sounding incorrect. You can really hear that if I make this into a same spinning time and choose a bit something like elect beep. Right, they're at the same time. Break this code, then start it. Oh, that was quite good. It's not quite right? So you can hear that? So again, this is another problem you wouldn't typically have in a normal programming environment. But when we're building musical systems and we're trying to make things simple, we want to solve this, right? Because if tonight, when you're all dancing like crazy to the music, and I make a mistake, as I will, right, and I can't fix it, because obviously a solution is, if I do this, break it, oh, sorry I've broken it, what I'm going to have to do, people, stop dancing, I'll stop the music, fix it, okay, now you can start dancing. It's not going to work, is it? So I need a way to be able to synchronize the threads live whilst the system's running without everything being correctly in time. So, how do I solve that? Well, have you ever heard of Lamports and Lamport clocks? Anyone heard of these things? Does anyone know who this guy is on my t-shirt? Who? Yes? Oh, he's got the same t-shirt. Okay, that's cheating. Yeah, anyone else know who this is? It's not George Lucas, someone said earlier. John McCarthy, he wrote Lisp. Right, so understand some computer science. Lamport clocks. Does anyone know what Lamport clocks are? Vector clocks? Who studied computer science? Come on, people. So Lamport, he did an amazing discovery about these things called vector clocks, which allowed you to synchronize in a distributed system time, right, in a way that makes sure that everything works in synchronization with each other by sending logical time across their messages across distributed nodes. You should definitely check it out. It's a beautiful paper, very, very simple idea. It's used all over the world today. But Sonic Pi uses Lamport clocks to allow you to synchronize threads. Well, what do we mean by that? So I can actually call this thing called sync and give it a keyword. Well, what does this do? Let's look at a simple way. If I call sync, actually that was good already there. If I got the sample, right, before I run the sample, I call sync foo, right? So if I run this code, that thread is blocked, waiting forever, waiting for a message called foo to be sent from another thread. Okay? So if it doesn't get a message, it's going to be there live locked forever. But over somewhere else, I can queue foo. And now that thread runs, the other thread, right? Let's try it again. So if I sync foo, if I queue foo bar, nothing happens. But if I queue foo, the other thread runs. Now, typically, thread barriers, if you know what thread barrier synchronization is? Okay, right, I'm going to teach you some stuff. Right? So if you have a bunch of threads, right, and you want them to actually work with each other in synchronization, one thing you can do is you can ask all the threads to wait for something to happen, like one thread to get past a particular point, then they can all continue, right? So it's a way of ensuring that threads are executed in a particular order, or this work is completed before this work. So this sync queue mechanism is exactly the same as that, right? And the other thread can send a message to this one to say, off you go, and then it can go. And that preserves the order of execution, which is one problem. But the second problem, and the hard problem, is they want to be in time with each other. And so what also happens is, for when the other thread sends the foo queue message, it also sends its logical timestamp, what time it was. It says, I was at 2 o'clock in the afternoon. And so the thread waiting, when it says, OK, you can start playing now, it also inherits that time, so that it's in temporal synchronization with the original thread. And so this allows me to solve this problem, because if I break this, I can actually say synchronize with foo, and they're in time. And this will always work, right? And so by allowing the thread barrier synchronization showing timestamps, which is essentially an implementation of Lamport clocks, I'm allowed to actually fix the problem of making sure people don't stop dancing, which is quite fun, but in a way that a 10-year-old child can understand. Because they don't need to understand all that stuff I just said to you about synchronization and threads and clocks. All they need to know is they can call sync, and it will wait for the other live loop to go round and then start again. Simple. And in fact, you can even put this sync command inside the definition of the live loop, and it will just do it the first time the live loop is created. So, yeah, it needs to be a key message. See how it works? Now I can get back to my loop industrial. It's always in time. Okay, does this make sense? No. But if you want to, the source code is all available. You can read about it, you can understand, if you want to understand how I built it. But the real message really is that this is incredibly simple code to work with, and it can create really dramatically interesting results. And the process of coming to this design is spending a lot of time thinking about how to make it simple enough for a 10-year-old child. Now, that might incur costs in terms of complexity of the underlying system. That's totally fine, as long as the interface is simple enough for people to use. And I really believe this is, and I've seen in schools in the UK, I've seen 10-year-old children perform using this system to their entire school in assemblies. And the kids have taught themselves how to do this. Well, this might look complicated to some people, but really it's not, it's just different. But what's more fun is that, could you imagine, could you imagine 10-year-old children saying, right, I'm going to do an assembly performance, let's do some sorting. Could you imagine that? No. So we've got to think about ways that kids are going to say, I want to do this. Because if kids are going to do it, an adult's going to do it, and if an adult's going to do it, then you can talk to them at parties. This is the whole goal, right? We want to be able to share the joy of coding with more people. Right? We need to find ways to engage them. And that's not the stuff that we do as professionals. If you think of us as legal writers of legal tomes, the equivalent of, we need to also think of what's the equivalent of a poem or a poet. What's the equivalent of a play? And these are the things, I believe, which are going to engage a broader audience, not enterprise software development, latest Java, whatever, Spring certified, master. Also, what is this about Java rock stars? I don't understand, right? Because I got, look at this. I got onto the Rolling Stone. That's a real rock star, not this Java rock star nonsense. And this is, to me, this is exciting. The fact that a music magazine can talk about code. It can talk about the fact that, this is a performance I did this Easter, that the shadowy DJ sets of knob-tweaking noise and fog bank ambient of many of the Mergfest performers was completely demystified, right? And turned into simple numbers and letters. This is what people want to see. We as programmers have the power to get into the Rolling Stone magazine by building simple systems which do amazing things. Why are we working on banking systems? Why? Why? Why are you using your incredible powers to make rich people richer? Why? Maybe it makes you richer, maybe that's the goal, fine. But I honestly believe that some of you in this audience might think, actually, I want to spend some of my time building something which is going to change the world, which doesn't necessarily have economic benefit. Right? Because the beautiful things in the world we see around us don't necessarily have economic benefits, do they? So why should always programming be associated with making money? And if we can do things like change the world in the ways that people can start to see code as a musical instrument and start to see that code can simplify problems and challenge DJs, right? What else could you challenge? I think that's really, really important and really, really exciting. So, is this making any sense at all? No idea. You seem to be, I'm not sure if you're interested or not. If you're interested, can you move your arms around? That's it, come on. I gave a workshop, a Clojure workshop. I love Clojure, so that's my JVM link, to a bunch of Finnish programmers, right? And they were all stone-faced, like this. I said to them, am I just boring? Or what is this? And as soon as I challenged them on the fact they had the stony face, they all burst out into laughter, because they realized that actually culturally, they don't tend to expose their excitement about things until you sort of poke them. So maybe this is the same with you guys. Hopefully, you're going to get excited inside about this, and you can start to see where you can go with this. Right, so I've got 5 more minutes. I'm going to just show you more of the things you can do with this system, which is a lot of fun. I can take a sample, like a loop amen, right, drum break. I can play it at half speed, hip-hop. I can play it at 1.5 speed, drum and bass. I can also do this. What's that going to do? Backwards. But there's another thing, right? Here's a challenge. What tends to happen in the 90s when people made sort of acid music and drum and bass music is they took that sample, this famous Amen break from the Winston Brothers on the B-side, and they chopped it up into small pieces manually with this GUI tools, and then they reordered the pieces and then played them back, and that created new kinds of drum breaks. So the question I got is, could I do that with code? Yes, not too hard, but could I do this in a way that a 10-year-old child could also do it? So I spent the last 6 months of my life solving this problem. And it's dead easy, actually, now. All I need to do is say, I'd like to play onset 0. Right? I just play the first bit, second bit, third bit. So now I can put this in a live loop called foo, and now I can sleep for a short amount of time, playing the first one. but I can pick one. Change the sustain time to be 0, the release time to be 0.1. Right, we've got an infinite stream now of random choices, but what gets really fun is if I iterate it 8 times and reset the random seed every time, I get the same pattern. Now, choosing a drum break is just a case of just putting a random number in here. That'd be nice with some reverb. You see what I'm doing? So this, I think, is really exciting because what we're doing is we're unleashing something which was only accessible to a very small number of people with expensive tools and lots and lots and lots of knowledge into something which a 10-year-old child can do. Now, there's some funky business going on here. What the hell is this? This is a lambda which has been passed into this function, which is then taking the list of onsets and choosing one and returning it, and then this is also then taking the arm end break sample, using a C library, using FFI, sending the WAV file using libsound, reading it in, doing feature detection on the whole WAV file, figuring out where the onsets are, returning those lists back through the C bridge, back to Ruby, which is then caching the value, and then figuring out what start and finishing points to use. But you just need to say pick, does all that for you. And again, this is important because kids don't want to do all that stuff. So there we are. And we can do this on anything. So if I have like a sample ebit arp, and I need to load up the other samples. Let's choose one that matches this and this. I know, I will not run this. Where, maybe I need to go home, figure this out. Why is this not working? No, okay, let's ignore that. I need to fix this before the party, so I'm going to sit and debug this in the corner. You can also do the same effect with not just drum samples, but with synthesizers and bass lines, and you can chop things up. Is this one going to work?
We can create
it's Rich Hickey, right?
Precisely the same programs we're creating right now with these tools of complexity, with drastically simpler tools. Right? I did C++ for a long time. I did Java. I did C#. I know how to make big systems in those languages, and I completely believe you do not need all that complexity.
And you should listen to the master, really. But I can now take Rich and repeat him round. Where's it? He's going to love me for doing this, but... All right. So you can literally do this with any sample and chop it off and play around. I think I'm almost running out of time. So, what else can I show you that's fun in the last 3 minutes? I think probably the thing to talk about really is that there is a help system built in with a full tutorial that you can download and you can read. So let's look at this. There we are. It's like a whole book basically built in. So you can learn how to do all these things if you want to, and it's written in a way you know nothing about code or music. You can learn both of those things with the system. We also have a crowdsourcing approach for translation. So this is, hopefully you might be interested in this. So there's 2 parts. There's the GUI itself, which we have translated to most of these languages. Let's find Russian. Russian's 86.5% translated. So one of you could turn that to 100% in probably half an hour. There's not that many more words to translate. which would be wicked. So if all of you spent 1 minute, that would be great. But there's also the tutorial, which is that massive, massive documentation, which is only 16.9% translated. So it'd be great if some people could join in, translate this to Russian, and then Russian children could be able to read this and learn all these things without having to learn English. And similarly, any other language, there's a bunch of languages which have already started here, but if your language isn't listed here, please join in and submit some translations for your language, and eventually we'll be able to crowdsource a full translation. And it will also help by saying, when I've changed a tutorial, it'll just give you the bits which have changed to be translated, or the bits which are new which are translated, so we can always keep the translations in synchronization with the English version, which is again trying to lower this barrier to entry. Okay, so I'll leave the rest of the music stuff for the party bit. I assure you it's going to be more interesting than what you just heard musically, but the techniques are all there, and hopefully you can be able to sort of, when I perform by projecting the code, you'll be able to follow on a little bit of what I'm doing, whilst drinking a beer and dancing. But the main thing I'd like to say is that, oh, stupid iTunes, go away, is that we should be trying to find ways to engage more people in programming, I believe. I think we have the skills to do that, and if we do, then we'll be able to go to parties and talk about programming more people, but also more people will be able to use the crazy powers we have to express themselves. That's the exciting thing, right? That's the beautiful thing. And so I believe we do that not by teaching people how to use Eclipse, not by teaching people how to use the development systems we already use today, but finding the things in their lives that they can do that programming can help, improve, or even offer new things, which is amazing, lots of different things. And when we do that, we should find ways to engage them in simple approaches, really simple. Because when things are hard and difficult, people will just switch off immediately. But also, when you make things simple, it actually opens up new possibilities. I previously worked in a music system based on closure called Overtone, which was really powerful, still is really powerful. And people are using it today, doing amazing things with it. But it's incredibly complicated to install. Like, you've got to get a JVM, you've got to get Linegan, you've got to pull the Maven dependencies down, all this nonsense. And then you've got to learn closure. And then, if you want to make a sound, you've got to design a synthesizer, which is already a lot of work, right? Whereas here, we just write the word play and choose a number. So if we make things simple, then what it turns out is that we can use this ourselves in new ways. Because it turns out that, it totally blew my mind, that we often talk about programming in terms of efficiency. How long does it take to solve the problem? How much memory does it take? How much CPU does it take, right? And we'll spend a long time working on a particular solution which fits those constraints as much as possible. But when we want to actually experiment, it turns out that the time it takes to have an idea and turn it into code also is a critical thing. And if we can not worry too much about the efficiency or the memory usage of it, but worry about how long it takes to get ideas from our brain to the code to seeing a result, then what that enables us to do is try more options out, play around in the space more fluidly. And what that means is that it gives us tools to express ourselves, because that's what it is. We're playing in that space. And so I think we should also be thinking when we program, not just about making things efficient in terms of the computer, but also efficient in terms of thinking and reasoning. So not just computational efficiency, but cognitive efficiency, communicative efficiency. How much effort does it take to communicate those ideas? Does that make sense? Because I really believe, we talk about, let's do one more second before I finish. We talk about big data. What on earth is that? It's lots of large log files, right? And businesses want to ask questions of that big data all the time. If it takes a day to come with a solution to the question the business person says, the business person is going to be very careful about what kinds of questions he or she is going to ask of the system, because it's going to cost a day per question. If it costs 5 minutes per question to answer, or 5 seconds, the business person is much more likely to ask crazy questions that they may or may not immediately see an advantage to, because some of the answers to the creative questions might be surprising, and that's where the business value is. Right? But if you're only being very safe and choosing very sensible questions of the business, then you're not necessarily going to get the most exciting results. If you're able to very quickly turn around the results from the questions, then you're much more likely just to play around and explore the space and get much more interesting results. And this is the same with music. When I make music, I just write some rubbish code and just keep changing it and changing it and changing it and changing it until it sounds good. And it's that exploration which is enabled by a simple system that I could never do with a complex system like Overtone with Clojure. Not in the sense that Clojure couldn't enable this, but just simple designs enable faster feedback, enable more play, more risk-taking, which can then yield better, more exciting results, whatever domain you're in, whether that domain is music, education, or banking, if you want to do that kind of stuff. Does that make sense? So, I invite you to download this thing, have a play with it, give me some feedback. Hopefully you'll come to, who's going to come to the party? One person. Thank you, Charlie. Okay, I'll look forward to seeing you later. Everyone else, if you do decide to change your minds, please come along. And I hope you're going to have a good time and dance, and I hope you read the code, and I hope you go away and think about who you wouldn't normally talk about programming to, and talk to them about it, and use systems like this to engage them, and hopefully get more people in the world programming a little bit. Not the same level as you, not professionally, just a little bit, so that they can learn how to express themselves in new ways. And then we'll have more fun at parties. Thank you very much.